Hi, it's Jan Beta and I'm back here in the lab with the very early Amiga 500 I inspected in the last video, and I'm going to try to carefully fix it to hopefully make it boot again in this video. As I said, I gave this an initial very close inspection in the last video, and I think everybody agrees that this is a super early Amiga 500. If you haven't watched the video, the link is in the video description, and basically I'm building this video upon the knowledge I gained from that video and also from the comments. They added a lot to the research that Stefan had done previously and my little bit of research that I did additionally, and led to more researching on my part. And possibly there are going to be more comments even on this video, hopefully. They always help a lot with getting things straight and rule out any mistakes that I might have made. One mistake that I made in the last video, which got pointed out pretty quickly in the comments, was that I falsely stated that the predominant language spoken in Belgium was French, which isn't the case at all. I was super ignorant. The majority of Belgians actually speak Dutch, and there's also a Flemish German minority in Belgium. I apologize for my ignorance of that fact. I hope nobody was too offended by that. Let's move on to the Amiga. So basically I'm going to start where we left off in the last part of this series, which might even be extended to more videos in the future. In the last video we determined that this Amiga doesn't start up. We just get a black screen. We don't even get a video sync signal. I did some preliminary stuff like spraying some contact cleaner into the Agnus socket, because these sockets are often a problem in these early Amiga 500s. And then I pretty much left the end as a cliffhanger. So in this video I'm going to start troubleshooting this, and the fact that it doesn't produce a video sync signal at all could mean several things. I gave this a visual inspection and I couldn't see anything horribly wrong with it, so no severely damaged components or anything like that. I reseated the chips. The problems that Stefan encountered while powering this on for the first time before I even got it, he described that he briefly got the LED on the keyboard assembly to light up, and he also got the drive to spin up, and then they kind of faded out and it didn't start up. I tried to start this up with the drive disconnected, the power to the drive also disconnected, the keyboard disconnected, and it still only produces a black screen. So that might point to a problem with the power supply to the board. So the first thing I'm going to do is to see if all our voltages from the power supply actually make it through this connector here to the board. There should be a 5 volts rail, which is the main rail that powers most of the chips and the logic and things like that. That is the most important one for this to start up at all. We also have 12 volts, which is primarily used for the disk drive motors and for the expansion ports. And we also have minus 12 volts, which is primarily used for the audio circuitry, because there's a differential amp in there that needs a positive and a negative voltage, and that's the 12 volts. So what I'm going to do is to power this on again and see if all those voltages from the power supply make it to the board. I'm using a known good power supply that I've used for a while that also has new capacitors in, and it's an original Amiga power supply that I kind of refurbished and have used for a while. So that's the most reliable power supply I have at the moment. That's what I'm using. Let's see what we get. I'm going to connect my ground lead here to a point on the PCB, which is a ground plane. And then we should have 5 volts going into the keyboard connector here on the leftmost pin and several other pins. And that seems to be hunky-dory. We get 5 volts there. Actually, we have a minus 12 bot wire here, which is labeled jumper minus 12, so that should be our minus 12 volts on here, which is also good. And for the 12 volts, that should be on the drive connector There should be 5 and 12 volts on there. Yeah, there's our 12 volts on the leftmost pin on the disk drive power connector here. So our voltages at least make it to this portion of the board. That seems to be good. So the connector for the power supply, which actually often is a problem because these get dirty or worn out and don't make good contact. But that seems to be all right. So far, so good. So my next step is going to measure the voltages going into the ICs actually. So the 5 volts should be present on all the respective pins on the ICs. And I think I want to start with the Denise chip. This is the 8362, which is the PAL version of the Denise graphics chips. I'm starting with this because we got a severely black screen without a video sync signal, so it might very well be that something's wrong in this area here. So the problem may very well be caused by a Denise that's not powering on at all. And a while back, somebody, I'm sorry, I don't really remember who sent this to me, somebody made this PDF which has little labels that you can put on the chips which have the pinout printed on them. So this is the exact size the chips have. You can cut these out and stick them to all the ICs in the old school Amigas and have the pinout just there, which is super handy. Sorry, I can't remember who sent this, but I hope you're okay with me linking the PDF for download in the video description, because this is such a handy tool. If you send this, please leave a comment or write me an email so I can credit this to you. There's no credit on here in the PDF itself. So the Denise chip should have the voltage supply 5 volts on the 6th pin from the left side here. This is pin 1. And pin 19 should be the VCC, which should be 5 volts. Oops, okay, that's a bit low. That's 0.15 volts. That should definitely be the pin that gets the supply voltage. And that's way low. And also after powering this on for a while, the ICs get slightly warm, but the Denise stays stone cold. So that is probably not powered at all. So that might be the problem, or one of the problems. So I went on and inspected this whole area here around the Denise chip a bit more closely, and I realized that this little resistor here, which is in the position that is labeled EMI 406. I don't know if you can see it on camera, but this has a little burnt spot. So maybe there's something wrong there. I didn't catch this in my initial visual inspection. This may be causing our issue. Here's a slightly different angle. Maybe you can see the brown spot a bit better. Usually if a resistor has a brown spot like that, that means it's probably open or at least has a very high resistance. Yeah, this should be a very low value resistor, I think. And indeed that resistor is brown, black, gold, gold, which would mean that it's a 1 ohm resistor. And it's super strange that it's in this footprint at all, which actually is labeled EMI and has 3 connections on the board. Usually there would be an EMI filter element in there, which are these here, which interestingly are present about everywhere else on the board where it says EMI. And these are just EMI filters for electromagnetical noise that they filter. So let's measure the resistance of our little resistor here. So this is in circuit, so there's probably a capacitor somewhere in there and the resistance is slowly rising, but it's definitely not 1 ohm. It's more like 330, 340 ohms. That's definitely not good. Of course, in circuit this can vary a bit, but this is definitely too high for a 1 ohm resistor. After finding that resistor, I did what any reasonable repairer of retro equipment does, and I took to the internet and Googled the EMI 406 in conjunction with the Amiga. And I found this forum thread in the English Amiga board, which is still in Christmassy mode, it seems, where somebody describes the exact same problem that Stefan described to me. Power LED comes on, then after several seconds it might go out, or the disk drive LED might come on. This is random. Caps lock light comes on normally and can be toggled. There's no video output at all, no disk activity. So that is pretty much what Stefan described. And this person also has a bad EMI 406, which also seems to be a resistor, interestingly, for this person. Drew on. A bit further down in this very same thread, several people reported similar problems and also a broken resistor in that EMI 406 position. So it seems to be a pretty common fault, actually. It is actually connected, as you can see here in this schematic. It is supplying the U4, which is the Denise chip, with the voltage. So it's a EMI filter that the VCC goes through directly. Interestingly, the component that is designated here in this schematic is a 0.01 microfarads capacitance, which these EMI filters, the three-legged ones, have. So probably there should be an EMI filter. No idea why Commodore changed that. Probably because it works better in some way like that. Probably they didn't need an additional EMI filter in there. I'm not sure. But we have a resistor here between our voltage supply and the chip we want to supply. So if that's broken, there's no voltage going to the chip, or very little voltage, like in our case. Yeah, it seems to be quite a common fault on these revision 3 boards, according to the forum thread there. There's several people, I think 3 or 4, reported the same fault. So, which makes this pretty common for the relatively rare revision 3 boards. I think this could easily be caused by somebody plugging in a monitor cable, for example, while the machine is powered on, or unplugging the monitor cable, because the resistor is just a 1/4 watt resistor, and that is directly hooked up to the voltage supply on the Denise chip. So in case there's more load on it than 250 milliampere, that's going to be stressed and burn out in the end. So probably, maybe, that is what happened to this Amiga. So there's actually a number of options I could try to fix this. In this forum thread it was suggested to just bridge these pins together, which I'm not going to do in order to not risk damaging anything. This resistor definitely is there for a reason. And probably it's mostly to limit the current to the Denise chip in case something goes wrong with the monitor cable here. So this resistor probably is placed there as a kind of fuse and a current limiting resistor rather than anything else. I could potentially replace this with one of these EMI filter things, electromagnetic interference filters. That's what the EMI means. But I think I want to replace it with the same 1/4 watt 1 ohm resistor that this machine had in originally. I think this resistor is actually what was in here from factory. I looked at several pictures of revision 3 boards online, and all of them had that resistor in that upright position, in this position. So I'm going to replace same with same. Also, of course, to retain the museum value that this machine has. And in order to do that, we are going to have to take the whole board out of this bottom case here, and the RF shield as well. So we're going to have to remove the disk drive, which is screwed through the case, through the RF shield, through the PCB, and then we're going to remove all the screws on these connectors and remove the bottom RF shield to be able to work on the board. There we go. There we go. That's our old disk drive. And in order to remove the PCB from the bottom RF shield, we're going to have to remove all these screws, which interestingly, some of them have been replaced with Phillips screws. I don't think these are original because usually they have these little posts where you can screw in the connectors. But this one has Phillips screws in these positions here, probably replaced at some point during its life. In any case, we have to remove all of these to get the board out of the RF shield. Speaking of PCBs, this is a good opportunity to thank the sponsor for this video, which is PCBWay, my favorite manufacturer of prototype PCBs of all kinds. You just send them your Gerber files that you designed at home at your desk, and they're going to send you high quality PCBs in no time for very reasonable prices. Their service is excellent. They also have CNC machining and 3D printing services, all of which are super useful for us retro enthusiasts. So check out the link in the video description. Back to the Amiga. So the PCB should now lift out of the bottom shielding here, which it does. And obviously there's an insulating plastic sheet in here, so the back of the PCB doesn't short out against the metal shield. And here's the board in all its glory. I suppose this is exactly how it came from factory. There don't seem to be any replaced chips or anything like that in here at all. And the back side of the board actually has revision 3 printed on it. 7th week of 87 as well. So this is definitely an early board revision. And also there's some spots where you can see solder residue, particularly in this area, which is the video circuit that we looked at previously. There seems to be a little solder bridge here, which I suppose is probably there to supply the video hybrid chip, which is this line here, with the voltages. So there's a cut trace here, and they botched this here. I think this is from factory, according to some research I did on the web. And probably they had an EMI filter in the position of the resistor, but then realized that there was no voltage supply going to the video hybrid chip. That's kind of interesting. So that's a factory botch, most likely. If anybody with a revision 3 board knows, please let me know if your board has this same botch. But I think it might just be a factory botch, and they placed the resistor in there deliberately to be able to supply both the Denise chip, which is here, and the hybrid from the same 5-volt supply rail. That's cut here and supplied through this botch here to the hybrid chip, I think. I just double checked this circuit on one of my revision 5 boards, and that actually has a proper 3-legged EMI component populated in this EMI 406 position, and it also doesn't have the botch on the back of the board. So I suppose they messed up the design slightly for the revision 3 board, and probably the originally intended 5-volt supply for the hybrid chip, which is this flat package here, wasn't clean enough for a clean picture or something like that. Not sure, but they botched in this resistor as a quick fix and put a solder bridge on the backside of the board. Looking at that, I just want to replace same with same and put a new resistor in here in this position and not mess with replacing this component with one of these EMI filters. So I'm carefully going to replace this resistor with a good one. And I'm going to use the exact same component, 1 ohm resistor here, brown, black, gold, gold, from my parts bin, which is also a 1/4 watt resistor, so it's the exact same. And I got it to look pretty much the same as originally, so I'm happy with this. Except for this resistor not being burned, obviously. And this new resistor now measures 1 ohm in circuit. So the other one was definitely bad. So I hope this at least fixes the 5-volt supply to the Denise, which ideally, if the Denise works, should give us a video sync, which would be a step further than we got previously with this just saying no signal when I turned it on. So fingers crossed. Let's see what it does. Okay, we get a PAL signal. That's better than before, but we still get a completely black screen, so more troubleshooting needed. So unfortunately it seems like we have other problems as well. There seems to be 4.7 volts now on the Denise chip, which should be enough to power it, and it actually gets warm. I think I'm going to remove the Denise chip and see if the voltage that arrives at the socket is actually the correct one. We obviously won't get any video signal at all now with the graphics chip removed, but maybe we can at least see if the voltage is good. That's 4.8. That's slightly low, I'd say. Let's see if the voltages on the other chips are okay. CPU should have voltage here. Yeah, that's more like it. That's exactly 5 volts more or less. So Paula gets its voltage. The CIAs have their VCC on this pin, pin 20. That's 5 volts. And Gary has its voltage on pin 48. This is also okay. So the Agnus get its voltage on pin 15, which should be this here. That's also 4.9, which is a tiny bit low. So all the main ICs should have enough voltage to actually power on and work. They usually have a tolerance of about 10% for the voltage supply. So 4.9 is absolutely not a problem. However, I think usually on later Amiga boards, the voltage from this particular power supply is very close to 5 volts on all the chips. So there may be something slightly pulling that rail down, which might indicate something being shorted or something like that, or having too low of a resistance. Another preliminary test that I'm going to do before I take to the oscilloscope is to see if we get the LEDs to light up on the keyboard. We at least should see the power LED coming on, because we have voltages on the keyboard connector. I measured those. But yeah, no. Don't get anything here. That's not good. So it seems we have an intermittent PAL signal now. Sometimes it locks into PAL and sometimes it doesn't. So yeah, let's check some basic things and see if this machine at least resets properly and things like that. So I sprayed some more contact cleaner into the Agnus socket and started poking around with the oscilloscope. And apparently, we now get a green screen every time I turn this Amiga on. So that indicates that the system itself is powering on fine, and that it powers on to a point where the kickstart error handling actually sets in. So that is very promising. The green screen, there are actually two different shades of green in the older kickstarts, the 1.2 and 1.3 versions. And dark green screen usually points to a problem with the RAM that also might be caused by an Agnus chip that's not quite working correctly or not sitting in the socket correctly. If it's a lighter shade of green than what we see here, it usually is an issue with the CIA chips. This seems to be a darker shade of green, and apparently that means that our Denise chip and the video output is working correctly, and that the kickstart is running. So the processor is probably fine, the kickstart is probably fine, the Denise is fine. I can't say anything about much of the rest of the system, but basic functionality is here, which is very promising. I'm still going to show you some things on the scope, I think, because I have that running anyway now. I have my scope set up in a rolling mode, I think. And we should see the reset circuit working. The reset line is on pin 3 of this 555 timer chip here, so that should be this pin. And it should turn high very briefly after I power the system on and then go low. That is the reset function. So let's see what it does. Yep. High and then low. And we get the green screen. So we can also probe the reset signal after it is reversed to the high status that the processor actually needs to run on this jumper 1 solder jumper that is after this transistor basically. So that should be low after I turn this on and then be high. There we go. That works fine. So the reset circuitry works absolutely no problems whatsoever. And we should also have a clock signal from our crystal here, which should be a clock signal at 28.375 megahertz. And you can see that it's around that. The scope is not super dead on, but this is our crystal that works fine. So a clock is there, which was to be expected if we get a green screen, obviously. So the processor seems to be running fine. That's just some very basic things you can check with the scope if the machine is not running at all. It's a good idea to see if the reset circuit is working and if the reset signal reaches the processor, which it clearly does. I didn't even measure it on the processor because the processor clearly is running if we get a green screen, and see if the clock is there from the crystal at all. So that's all hunky-dory. So here's an interesting thing that I observed. Whenever I hit the Agnus, we get some problems with the signal. And when I move this chip, the signal changes, the video signal. So everything basically points to the Agnus socket being bad, especially since it has some corrosion on the pins. And cleaning it made things a lot better and made the green screen appear in the first place. So I think there's no way around replacing this socket altogether to be sure that that fault can be ruled out. So here's a close-up of the Agnus socket, and you can probably see on camera in this back row of pins there's some relatively green ones here. So this socket definitely has some corrosion. And as I said previously, these PLCC sockets are not very reliable, even if they are not corroded. And thankfully I have a couple of replacement options in my parts bin. I'm going to use one of the black ones, even though I think the brown ones are better quality. But as this is such an old piece of tech and the historic value is kind of important, I'm going to use one of the black ones to match the original look. So I'm carefully removing the Agnus chip. There's a couple of options. You can use one of these PLCC pullers, which are specialized to clip under these chips with these hooks and then slowly pull it out by pushing it together. But there's also the option of poking something in here and pushing out the chip from the bottom of the board if you have the board out. I'm going to try like this. And you don't want to use a screwdriver or anything like that to get these chips out, because you are going to damage the socket. There we go. That went relatively easy. And the pins on the chip look relatively clean. The socket, on the other hand, looks... okay, there's a problem there. Let me show you. The row of pins here is corroded a bit. That's not the worst thing, but some of the pins are pushed in. Look at these here. They are completely pushed in and they are not going to contact the pins on the chip, which are kind of folded under the chip for these PLCC packages. So no chance these pins are going to contact the socket in any reasonable way. So I'm going to desolder this carefully and put in another one. That might very well be the cause of all our problems. I'm going to fire up my desoldering station and try to desolder this. These boards are thinner than later versions, so I'm going to try to be super careful with it. Probably not as easy to work on as the newer versions of the A500 boards are. So I just checked if each and every pin is freed, and they should be loose. I'm slowly wiggling this. Just slightly moving the pins with my fingernail here, and now we should be completely and utterly free, I believe. There we go. Not too bad. Don't think I damaged anything. But there seems to be some corrosion underneath here even. Look at this area here. That is where the corroded pins on the socket are as well. So maybe something got in there. Might just be a bit of a soft drink or something like that and corroded the board in this spot. The rest of the board looks very clean and not corroded at all. So this is kind of strange why there would be corrosion only in this spot. But this clearly is, they look a bit dull and kind of corroded. So I'm going to clean this up with some alcohol and a brush and see if we can get rid of all that. Still looks a tiny bit corroded. I think I want to use my fiberglass pen for a bit to just clean them up completely before I solder the new socket in. Just a quick wipe. Yeah, that looks reasonable. The back side looks very good, so not much cleaning to do there. And I don't think I damaged any traces. Top side looks good. Bottom side, it appears that everything is still good. Let's put the new socket in. These replacement sockets I have actually have a little arrow pointing to pin 1 and there's a 1 on the board. So these have an orientation. There we go. And now it's just a matter of soldering in all the little legs there. I'm going to clean this up a little more, but all the pins are soldered in and seem to be making contact, at least from this visual inspection. Should be good to go. And the new socket also looks way better than the old corroded one from this side. It looks a bit different, but it probably would be impossible to source one of these original ones. It's a PLCC socket that is going to work better than the original one. And it looks close enough to the original one, I guess. So we're going to put the Agnus back in, I guess. I'm going to give this a tiny bit of a wipe with some alcohol as well before I put it back in though, because some of the pins look a tiny bit greenish as well. So I hope get all that corrosion off there. Here's the back of the chip for documentary purposes, by the way. You can see this little dot that indicates pin 1, Philippines, IM 082909, HC30 is what it says here. Whatever that means. I'm also going to spray this with contact cleaner slightly, so we're going to have a good connection in the socket. And in it goes. This is pin 1, just checking, double checking and triple checking. Okay, now we want to push this down evenly. felt positive. Okay, I'm mildly excited. Maybe this fixes the Amiga. We're going to see. That's very promising. Do we see the Kickstart logo? Yes! It's fixed! So obviously we have to perform some more tests on this, but at least it boots up to the Kickstart screen with the Kickstart 1.2 logo, which is the first Kickstart the Amiga 2000 and the A500 shipped with. So that is probably the original Kickstart that was in here. All the chips that are in here are the original chips, as far as I can tell from the date codes. So that's pretty amazing. They seem to still work fine. Yeah, I don't know what to say. I'm super relieved. This was such an easy fix. Well, desoldering and resoldering these PLCC sockets is not the easiest operation, but I've done that a couple of times and usually it works pretty well. And the original socket was beyond repair, so I'm glad I did that. And I'm glad that we got to this screen at least. And it also appears to be stable now. I can touch the Agnus without any change of picture. That definitely was the fault. Or one of the faults. We still don't know if everything works, but yeah. And I hooked the keyboard up to this now, and apparently we now have the LEDs both come on, and then the drive LED, after it looks for the disk drive, it goes off and we get the Kickstart logo. On these early revision Amigas, the power LED, which is red on the earlier models, only has two states, which are on and off, basically. It doesn't have the audio filter, which is also connected to the same line that handles the LED brightness. On the Rev 5 boards, if the LED goes off during operation, the audio filter, the high-pass filter, is engaged, and on these there is no audio filter. So that just does nothing, and the LED doesn't change and the filter doesn't change. On some later models, the LED is not completely turned off. I think that behavior starts with revision 6 of the boards, and also later they changed the colors to comply with their other models. In later Amiga 500s we have a green LED for power and I think an orange LED for the drive activity LED. Let's see if we can perform a keyboard reset. Amiga control, or in this case, Amiga Commodore logo control. Yup, that works, no problems whatsoever. Winner! The caps lock key flashes. Okay, so we have another problem. So the LED on the caps lock key is actually used for further fault indication, and this flashes in a way that is not very promising. And also I can't turn it on and off. I think it flashes 3 times quickly and then turns off for a second. I have to look that up. So I consulted the internet, and apparently Amigalove.com, which is a very recommended website anyway for all your Amiga communications and also some excellent troubleshooting guides. And there's the most accurate and concise list of Amiga boot up screen colors and system errors on that site that I'm also going to link in the video description. It also has the caps lock key LED blinks. And 3 blinks actually means a watchdog timer failure. The watchdog timer actually has to do with the CPU timings and usually means something is utterly not working. And there is a little circuit on here that checks those timings, I think. And if the timings are not correct, the caps lock key is going to go into the error blinking mode. But apparently, after reseating the keyboard plug on the mainboard, the caps lock key doesn't flash anymore and it behaves as it should. If you can turn this on and off for more than 6 or so times, that means that the processor is correctly communicating with the keyboard. These keys actually feel way better than the later keyboards. These are real mechanical switches. Long story short, this now works as intended. I think I'm going to spray some contact cleaner into that keyboard connector and we're probably going to be good. At least on the watchdog timer front. Yeah, so I'm just going to spray some more contact cleaner into that and also clean the connector on the board, and that issue should be solved, hopefully. Sometimes the capacitors on the little keyboard PCB go bad. That might also be the cause. Back with the 3 flushes. So there's an intermittent fault there. No flashing. Yeah, I'm almost certain it's an issue with the connector there. So yeah, we're going to leave that at that, I guess, for the moment and keep an eye on it. Just to confirm my theory that the fault has something to do with this keyboard circuit, I now hooked up my spares keyboard, which is in the poorest state imaginable. I don't know what it is that's on here, but it's super difficult to clean this, so I just use it for spares. And this was missing some keys when I got it that were replaced with this little bumper things. So I'm using this for whenever I need a keyboard spring or anything like that. I also salvaged the original power LED. I have this makeshift LED soldered in here so we get some indication, and the caps lock key LED also works. So let's see if we get the same behavior from this. So this actually has a green caps lock LED because it's a later revision, obviously, with the other one being one of the earliest. But this is from a revision 6A Amiga 500, I believe. So it has a green caps lock LED already, which later revisions had. So let's see what it does. If I turn the Amiga on, this should power up briefly. The LED should come on, and then it should not flash. Yeah, there we go. Came on briefly. The makeshift power LED also came on, but the caps lock LED is not flashing. That would point towards a failure with either the connection or the circuit on the keyboard itself. And just for giggles, here's my makeshift power LED in action. Yay! Yeah, the connector on these later keyboard models also fits the connector on the board way better. It actually plugs in all the way. So here's the original connector, and as you can see there's a 1mm gap or so. I can't push it in any further than that, so that's kind of shoddy. And I think it actually might just be a connection issue. At this point I kind of want to see if our disk drive works. So we're going to hook that up like so. Okay, let's see if we get the drive ticking. And it actually doesn't do anything. Just going to put a disk in. Oh, look at that. Okay. It doesn't read the disk, but that's a start. It's actually reacting. And the drive doesn't tick, which it technically should do. Now the drive is ticking. Okay. I just reseated some of those connectors there. Yeah, but it doesn't want to read this disk, which is a known good disk. Something's still wrong there. Probably going to resolder some of the solder joints around those connectors on the board there. And now we get a tick from the disk drive. I don't know if you can hear that. It ticks. The tick of life. That's kind of intermittent, so we are going to have to do some more work on this. So I'm just going to reflow all these connectors, the pin headers that are here for the disk drive and the keyboard. They look kind of dried up. I can't really see any cracks, but we're going to add some fresh solder and see if that makes things work more reliably. Just going to add a tiny amount of solder to each of these pins, just to make sure there are no cracked joints. Now that I got the machine running, at least starting up to the kickstart screen, I put a diagram in here, which is a Diagnostics ROM that you replace the kickstart ROM with, and that has all kinds of tests for the system on board. In these older boards, the revision 3 and the revision 5, you can't just put an EEPROM into the socket, you need to connect some pins, so I'm using an adapter here, hence the tower. So we're not quite playing Turrican on this yet, but everything else seems to be pretty promising. The diagram startup is flashing the screen, so that's normal behavior. And there's our diagram in action. Let's enter the sysinfo. Keyboard is a bit intermittent, so we probably have to do some cleaning on the switches. That's our system. And that all shows up in green, so that's probably good. Audio tests. Channel 1, channel 2, channel 3, channel 4. Yay! That seems to work. Filter. You can turn the LED on and off with the audio filter address, but apparently there's no change in the sound. So the audio filter is not turned on and off, but the LED is. Interesting, I didn't know that. Audio seems to work fine. Let's go back to the main menu. Memory tests, that's going to be interesting. This is actually testing all the memory locations, so that's a pretty in-depth test for the RAM, which is of course good if it turns out to work. It's looking good so far, still looking good. Okay, we have an address error, not quite sure if that is good. Let's see if our CIAs are testing good. Okay, so level 7 will always fail until you press an IQ7 button. Okay, that's all good. The CIAs are good. Oops. Graphics seem to work fine. Yep. Another test screen. Okay, we have this line cut off here, but I just think that's because my upscaler cuts the screen. There. Scroll test. Yay. Test raster. That looks good. Flicker is normal. RGB test. Okay, that looks cool. So port tests we can't really do because we don't have a test harness. Drive tests, we don't have a disk drive connected. Keyboard tests. Let's see. Yeah, we get keyboard activity there. Yeah, the keyboard seems to work. It's just a bit flaky because probably the contacts need some cleaning. I think the memory test failing might be because of an issue with the old Gary chip, probably. These early revision Gary chips have some timing issues, I think, and they fixed those later. There was a workaround with a little transistor mod that you could do to fix that. The Gary had some issues that even prevented some games from working correctly and things like that. So maybe that's why the standard memory test failed on this. I'm not quite sure. If anybody has tried with the old Gary chips, let me know. Otherwise, this seems to pass the tests that make sense. And it also passed the extended memory test. So I guess the Amiga itself is pretty much okay. As the disk drive doesn't work yet, we're going to take a look at that in a second. I have hooked up a GoTech disk drive emulator for now. And we're running the Amiga test kit by Keir Fraser. And apparently this runs fine, so the disk drive, if it was working, it would run fine. The Gotek is just a replacement for a working disk drive. And the memory tests and all the tests in the Amiga test kit actually pass. So I think that the strange timing errors that were displayed in the diagram test are due to the Gary chip, which is an early revision and that has some timing issues. So everything else seems to work just fine, which is amazing. The keyboard is a tiny bit flaky. Especially the escape key doesn't work every time. We're going to take a look at that. And I still occasionally get the flashes from the caps lock key, but other than that, this machine seems to be absolutely fine. And also we can play Turrican. That's also running from the Gotek because the disk drive doesn't work yet. It appears the Amiga PCB is absolutely fine, which is amazing. Okay, so let's see if we can get this disk drive to run. I'm going to remove the cables carefully. And I need some very small screwdrivers to remove this shield here. This is what we can see of the backside. And I can already see that there are some electrolytic capacitors on here. Usually these drives are fixable by cleaning them and by lubricating them, and sometimes the capacitors on these go bad. I've very seldomly seen them misaligned or anything like that. I said usually these drives can be brought back. Not too sure about this one because I've never worked on this model. I'm going to remove these screws, which should allow me to remove the top shielding and take a look at the mechanics. Yeah, that was easy. Yeah, there's a lot of dust in here, as you can see. So I think my first step is going to be cleaning this a bit. And there's our heads. There's one top head and one bottom head there. Top head. So yeah, I'm going to clean the heads. And there's also a rail in here that the head assembly travels on so it can change tracks on the spinning disc. And that is a very common cause for these things not working correctly. The lubricant hardens over time, so it's not going to travel easily anymore, and that causes all kinds of faults with these drives. So I'm probably going to clean the rail and the heads and maybe put some contact cleaner into strategic spots. Yeah, so I'm going to go into all the little cavities here as far as I can and clean all the dust. And then I'm going to re-lubricate this rail, and as my last step I'm carefully going to clean these heads with the Q-tip that I put in there. I'm not going to show you this whole process, but hopefully we're going to end up with a drive that's a lot cleaner and better lubricated. Yeah, one thing that's worth mentioning probably is you want to clean the old lubricant off that rail as well as you can before you re-lubricate it. And I'm using silicone grease, standard silicone grease for lubricating those parts here. This is the silicone grease I'm using. Standard stuff. Now I'm soaking a Q-tip in some alcohol and I'm going to go in here and carefully wipe those heads, although they look very clean. One last thing that I want to do is to spray some contact cleaner into some strategic places. One of the spots I want to spray some contact cleaner in are these two white protrusions that are coming out of this black box. These are actually switches to notify the drive of disk changes, and also if the write protection is engaged. There's the hole there. If that hole is open, one of these is going to pop through that. That's actually a pretty common fault because these tend to get dusty. Let's spray some contact cleaner in there and work them a little bit. That usually helps a fair bit. Just so the contact cleaner actually goes in there. Yeah, that's basically all I want to do at this point. 80% or something like that of all the disk drives I worked with could be fixed that way, because it was just some stuck lubricant, like some decades old silicone grease that got stuck and the head couldn't move freely. Let's see if we get any signs of life from this, or more signs of life than previously. It is ticking. Let's put the Turrican 2 disk in there for a start. Nope, it's not reading. Okay, let's put a known working disk in there from my stash. It definitely... Oh, look at that! I was about to say it definitely recognizes disk changes, but this just booted straight up. So that's a very good sign. Okay, so it boots some disks, but not all of them. Okay, so it's not 100% working, it seems, but it's still way better than before. Yeah, so what's my next step? I might want to go in and try to replace those capacitors. We may be able to at least take a look at these circuit boards after removing these screws and the screw on the side here. Oh, there's plastic inserts here. Okay. These screws are in these plastic clips. Yeah, but we can remove these here now. Yeah, so I'm just going to try to see all the values printed on here and note them down and then put it back together for now, I think. Okay, I noted the values down, and some of these are actually bipolar caps. So this is bipolar, these two are bipolar, the other ones are polarized. These are going to be even more difficult, if not impossible, to get in these sizes. So that's going to be a challenge. But I've noted all the values down, so maybe I'm going to get back to this. For now, I'm just closing the case. Literally. The last thing I want to take a look at in this video is the memory expansion that Stefan thankfully removed altogether and even sent it in a separate parcel. So thanks for that. These are super nasty because, as you can see, there's a battery on here that has leaked already. We're going to take a look at this. Maybe we can even resurrect it to some extent. There's quite a bit of corrosion on here, but the RAM chips, 512K in total, are fine, thankfully, it seems. No corrosion on those pins. The corrosion is around the battery area, and I can see some green spots there, also on the back side. So I'm going to remove the battery with the correct tool. And then what I usually do is to neutralize the battery leakage, which is actually a basic liquid that's leaking out of these batteries. So you can use something acidic to neutralize the corrosion here, or the leakage. The corrosion is not going to be neutralized. We're going to have to work on that separately. I'm going to put some white vinegar on this circuit board and then rinse it with some distilled water after letting it soak in for a while, and then try to remove the green spots, which is corroded copper basically. This is just a box standard white vinegar from my kitchen. Actually from my kitchen. So I'm just getting some on all the corroded spots here. And I'm going to let it sink in. So, off camera, obviously, this soaked in vinegar for half an hour or so, and I'm now going to wash the PCB with some distilled water and also with some alcohol to get the vinegar off, which would otherwise cause the same corrosion, but from the other side of the chemical spectrum. May this be a reminder to always take the batteries out of your devices that you put in storage, even if it's just a little rechargeable battery on a memory expansion like this. We just want to remove all that green stuff. The battery is not crucially important, it's just for the battery-backed clock on here. That doesn't affect the memory expansion. So that's about as far as I want to go with this. I don't want to spend too much time on this. I'm going to rinse it with alcohol, let it dry, and then try if this works. I noticed a minor amount of green on the expansion connector on the Amiga, so I'm carefully doing basically the same treatment, just some vinegar in there, and then I'm going to try to remove that. Yeah, that works reasonably well, really. So it's just surface corrosion, thankfully. I would like to keep this as original as possible, so I'm just going to remove this corrosion here and wash it with some alcohol. So let's put our memory expansion on here. Should just be a matter of placing it and pushing it in. There we go. First of all, we need to see if this still boots up, which would be a good sign. Yep, it does. So chances are this memory expansion is just going to work fine. And we can still boot our Amiga test kit. From the original disk drive, this machine very likely came with. So that's kind of amazing. Even if it doesn't boot anything else. Progress. Oh, it doesn't detect the fast RAM. Okay. So there's that. I just realized I might just have made a very rookie mistake. As you can maybe see, there's a little jumper on here, or a pin header for a jumper. And that's usually where the switch that switches this whole memory expansion on and off connects. So chances are that it's on when this jumper is closed. So I'm going to put a jumper on there and try again. Maybe that's the fix. Oh, look at that. It's not fast memory, it's slow memory. Pardon me. And now it's detected now correctly. Let's see if our memory fully works. I'm going to let this run for a while to see if we get any memory errors. But I think usually these chips are super reliable, especially the newer ones that are on the memory expansion. So yeah, it passes the test. This is round 3 of tests. So this memory expansion also works fine, it seems. It's just a bit corroded. So it might be worth to just give it a bit of a more thorough cleaning, and we can at least use this as a memory expansion without the battery backed up clock. Could also put a new battery on there, but yeah, usually that's not really worth it for these things. Yeah, I guess that's it for this video. The Amiga itself seems to work fine. The memory expansion also works. I'm super happy that I got the Amiga working again, and it seems to work super reliably. Played some games on this and things like that from the GoTech. The disk drive still doesn't want to work, as you've seen. The keyboard still has some issues. Some of the keys don't register every time you press them, so there is going to be another episode where I clean the keyboard, clean the case parts, maybe try to fix the floppy disk drive again. Not sure how, but we're going to see. Maybe you have some ideas. Leave them in the comments. I'm also going to ask you, the community, for your opinion about how to proceed with this. I'm considering recapping the whole machine to hopefully make it last even longer than it normally would. That would be an option. The other option is to leave it as is, just clean everything meticulously, the case and the keyboard, and leave everything as is in its museum condition. Because it is kind of a museum piece. All the chips that are in here are the original chips this machine came with. It's a bit of a pity that the disk drive isn't working yet, so probably would be a good idea to put a replacement disk drive in there if this machine should see some use in the future. And I guess that's the best option. I'm not sure. Let me know what you think in the comments. I'm also going to run polls probably about this question to have you decide democratically. Thank you so much for watching. I hope you enjoyed this. I'm super happy that this is working again. Special thanks to Stefan for letting me work on this museum piece and trusting me with it. And also special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page. Very much appreciated. Thank you so much. I think that's it for today. Hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye.